Hello students, let's continue with solving linear inequalities in one variable. And now this is part 2. Now, consider the inequality 7 is less than 10. Okay? Now, when we add there 2 on both sides of the inequality, does it reverse the sign of inequality? Let's check. When we have 7 plus 2, we will have 9. Then 10 plus 2, we will have 12. So you see that 9 is less than 12. So you see that the sign of inequality has not reversed. Look, when we subtract the same number on both sides of the inequality, let's say minus 6 and minus 6. This side we will have 7 minus 6 to have 1, and this side we get 10 minus 6 to get 4. You still see that 1 is less than 4. So still the sign of inequality has not reversed. Okay? Now, what do you think? 7 is less than 10 and a is a real number. What happens if I have 7 plus a and 10 plus a? It implies that still the sign will be less than. And if we subtract a from both sides of the inequality, still the sign will remain as less than. Let's look at the next part. We have 10 is more than 7. What happens if we add 2 on both sides of the inequality, or any other number that is same? You see that 10 plus 2 is 12, 7 plus 2 is 9, and we know that 12 is more than 9. You see that the sign did not reverse. And what happens if we subtract the same number from both sides of the inequality? Here we will have 4 and here we will have 1, and we know that 4 is more than 1. You see that the sign did not reverse. Okay? Now, 10 is more than 7 and a is a real number. What do you think will happen if we add a on both sides of the inequality? Will the sign reverse or not reverse? You see that the sign will not reverse. And what happens if we subtract a from both sides of the inequality? Okay? From what we have seen here, it implies that still the sign will not reverse. So, how do we conclude? We can make a conclusion that adding or subtracting the same number on both sides of the inequality does not reverse the sign of inequality. Now, what do you think? If we have 7 is less than or equal to 10, if we add 2 on both sides of the inequality, will the sign reverse or not reverse? What do you think? You can give your suggestions in the comments section. Look, what happens if we subtract 6 from both sides of the inequality? Will the sign reverse or not reverse? If we have 10 is more than 7 and we add 2 on both sides of the inequality, will the sign reverse or not reverse? If we subtract 6 from both sides of the inequality, Will the sign reverse or not reverse? Please give your suggestions. Okay, for now, let's move on. We will have some examples. Solve each of the following inequalities and illustrate the solutions on a number line. Okay, part 2. Solve the inequality 8 minus x is more than 3. Illustrate the solution on a number line and answer the following questions. Find the largest prime value of x that satisfies the inequality. Find the positive integer value of x that satisfies the inequality. Okay, now we begin our solutions. We have x plus 4 is less than 3. Okay, now we will subtract 4 from both sides of the inequality. But what happens if we subtract 4 from both sides of the inequality? Will the sign reverse or not reverse? We know that the sign will not reverse. Okay, so then we have x is less than negative 1. Okay, now what does this mean? It means that the solutions to this inequality are all real numbers that are less than negative 1. And if we substitute any real number that is less than negative 2, the inequality will always be true. Okay, now let's show this on a number line. Since we are having less than, we will be using an open circle and then we will be moving to the left. So you can see that if we substitute x with negative 2, we will have negative 2 is less than negative 1, which is correct. Get negative 3. We substitute it with x. We have negative 3 is less than negative 1, which is correct. You see? Therefore, the solutions of the inequality x plus 4 is less than 3 are the real numbers less than negative 1. I believe that you have really understood this. Let's move on. We have negative 4x minus 5 is more than or equal to 11. Okay? Let us add 5 on both sides of the inequality. But then what happens if we add 5 on both sides of the inequality? Will the sign of the inequality reverse or not reverse? From what we have seen already, we know that the sign will not reverse. So then we will have minus 4x is more than 16, because actually we know that minus 5 plus 5 is a 0. Okay, now at this step we will divide both sides of the inequality by negative 4. But then if we do that, what will happen? Will the sign reverse or not reverse? Remember, we are dividing by negative 4 on both sides. Remember that dividing by a negative reverses the sign of the inequality. So the sign of inequality will now be less than or equal to. Now finally we get x is less than or equal to negative 4. Okay, it implies that the solutions to this inequality are all real numbers that are less than or equal to negative 4. We can show this on the number line. Okay, So because we are having less than or equal to, we will be using a closed circle, and then we move to the left. This means that, for example, if I get negative 4, I substitute it with x, I will still have the inequality true, because we know that negative 4 is less than or equal to negative 4. If I put negative 5 here, I substitute x with negative 5, I know that negative 5 is less than or equal to negative 4. So you can see that for sure the solutions to this inequality are all real numbers that are less than or equal to negative 4. Okay? Now, solve the inequality 8 minus x is more than or equal to 3. Illustrate the solution on a number line and answer the following questions. Number 1, find the largest prime value of x that satisfies the inequality. 2, find the positive integer values of x that satisfies the inequality. Now, let us begin with solving the inequality. 8 minus x is more than 3. Okay? Let us subtract 8 from both sides of the inequality. Does this reverse the sign of inequality or not? We know that it doesn't reverse the sign of the inequality. So then we remain with minus x is more than minus 5. Okay? Now, at this point, we will divide by negative 1 on both sides of the inequality. But now, what happens if we are dividing by negative 1 on both sides? Remember that dividing by a negative number on both sides of inequality reverses the inequality. So, we will reverse the inequality to get less than, okay, instead of more than. And finally, we get x is less than 5. Let us show this on a number line. Since we are having less than, then we will be using an open circle, and then we move to the left. Now you can see that the solutions to this inequality are all real numbers that are less than 5. For example, let's substitute x with 4. We have 4 is less than 5, which is correct. Substitute x with 3. Let's put 3 here. We will have 3 is less than 5, which is correct. Okay? Now let's answer the first question. Find the largest prime value of x. What are prime numbers? We know that prime numbers, these are numbers with only 2 factors, 1 and itself. Now, from these solutions, which one is the largest prime number? We know that 5 is not included in the solutions. We know that 4 is not a prime number. We know that 3 is a prime number. So the largest prime value is 3. Okay? The largest prime value that satisfies the inequality is 3. Part 2. Find the positive integer values of x that satisfies the inequality. We want only positive integer values. We know that 5 is not inclusive. So we go to 4, 3, 2, and 1. We cannot say 0. 0 is not positive or negative. So we say that the positive integers are 1, 2, 3, and 4. These are the positive integer values of x that satisfies the inequality. I believe that you have really understood. Now, you will pause the video and solve each of the following inequalities and illustrate the solutions on a number line. Thank you and have a good day.